So radians to degrees, or degrees to radians, radians to degrees. Pressing this. So if you put the pi in, and you press math enter, enter, no matter how hard you press it. Remember, if you like press it extremely hard, it's never going to give you a fraction. Do you agree? No matter how much you press that button? Because pi can't be turned into a fraction, because fractions only come from terminating decimals and repeating decimals. Do you agree? Pi is neither of those, so it can't turn into it. So if I wanted to type this one into my calculator to check it, I have negative 7 pi over 6 plus 2 pi. How did I tell you to deal with them on your unit circle? If you wanted to type them in and get fractions out. Leave out the what? Leave out the pi. So type these in. Go negative 7 over 6 plus 2. Leave out the pi. Try it out. That's a way to check. Remember, you have the alpha y equals enter button. If you have the new ones, you can use that as a fraction. If you have the old ones, you have to put it in brackets. It's the only way your calculator knows it's a fraction, right? Everyone testing it out because you are the only one who's using your calculator on your test. So we just put them in without the pi's. There's always someone who calls me over and says it doesn't turn to a fraction and you put in the pi's. Oh, Sean. So negative 7 over 6 in brackets plus 2. And when you hit math enter, enter, it gets you 5 over 6, doesn't it? What do we have to bring back? The pi. So it's a way to check it. Okay, I want you to try the 7 pi over 3 one. Get it to the coterminal. 7 pi over 3 is 2. Big. So am I going to have to add 2 pi? Subtract 2 pi. So try it out. So we're going to subtract 2 pi from here. It's over 1, so I need to make it over 3. So I'm going to multiply by 3 and multiply by 3. So I get 7 pi over 3 minus 6 pi over 3. And I tell you always, always, always that this is what to this? What should I have down the left-hand side? Equals. If the equation already has an equal sign, do I add an equal sign down the left? No. If it has an equal sign, the equal sign just follows its way down. If it doesn't have an equal sign, it's an expression, then you write it down the left-hand side. Now 7 pi minus 6 pi is 1 pi over 3, which is on your unit circle. Negative 135. Too small, so I have to add 360, and I get 225, which is a principal angle between 0 and 360, so I'm done. So we did coterminals before this already, too. What else did we do? I gave you, sorry? We did that, but previous to that, remember I would say something was on the unit circle. What did that mean? Yes, on the unit circle. Whenever you see that, you think, hey, I can use the unit circle equation, which is x squared plus y squared equals 1. And the reason why I showed you is because you can add a 0 to the x and add a 0 to the y, because that's the center of the unit circle, and radius is 1 squared, right, which is 1. So that's why it's x squared plus y squared equals 1. Now, I can ask you this. I can say x comma 3/4 is on the unit circle. What do I have to give you as well? Remember? I can't just give you a point. If I give you a point, you can get 2. What quadrant it's in. If I don't give you the quadrant, you have 2 answers. You have a positive x and a negative x, because when we take the square root of anything, we get plus or minus, right? I'm going to say that it is in quadrant 3.
So how is you're going to have to make that 3/4?
I see nothing. Determine the value of x. I was putting quadrant 2, so I was going to be a rebel, and then that backfired miserably. Okay, so we're going to try that one out. I also want the coordinate on the unit circle. This is not using the formula. At a 5 pi over 6 and b 12 degrees. I want the full coordinate. This was not one lesson. I'm better. 9 over 16 equals 1. Yes, it is. F, I don't even know if it would be an F. It would be more Z, because I keep forgetting to press it completely. Okay, so we're going to go x squared equals 1 minus 9 over 16. 1 can turn into what? Need a common denominator of 16. So I can just write it as 16 over 16. So I'm going to get x squared equals 7 over 16. Now, guys, remember yesterday the day before, I told you that we were taught this in grade 10, right? We were taught that we take plus or minus, that's great. We were also taught that there are instances where we can put the whole fraction under a radical, and there's instances where we can do what? Write them separate. And why do we write them separate?
Because some cannot square root to a whole number.
Right. So whenever one of either the numerator or the denominator is a perfect square, we will split the radical up. Okay? So we're going to have x equals plus or minus root 7 over root 16, which is actually plus or minus root 7 over 4. And we know in quadrant 3, what's our x? X is our what in quadrant 3? Negative. And there's our answer. Okay. Then we did coordinates on the unit circle. So we went to 5 pi over 6. 5 pi over 6 is in quadrant 2. It's a 30-degree reference angle because it has a base of 6. Remember what numbers are on the bottom that we know that they're reference angles on the unit circle with radian measure? 6, 4, 3, and 2. Because 2 gets you the arms, gets you the y-axis. Right? So if we have 3, 4, 6, or 2, we're going to land on the y-axis. 5 pi over 6 is a 30, and so it's going to be negative root 3 over 2.5. Most people can get that because they can just find it and give it to me, correct? 12 degrees pops up, weird random angles pop up on diplomas all the time. And so you guys will stand and you'll look at the unit circle and then you get mad because it's not there and then you don't know what to do. But remember we talked about Calgary Stampede and we talked about that the unit circle is always cos theta sine theta. And we talked about how we could find them on this one. This one is cos 5 pi over 6. And this is the answer to sine 5 pi over 6, right? We were asked about those yesterday. So remember your coordinate is always cos then sine. We agree? So for this one, instead of it being cos of 5 pi over 6 and sine of 5 pi over 6, this one's going to be cos of 12 and sine of 12. And then they usually do 3 decimal places or something like that. Now, remember, we're going to go touch the cos button or the sine button. If we press the cos, the sine, or the tan button, we slap our hands first and we ask ourselves, what mode do I need to be in? So, what does this have to be in? Ryder is backing Sean. 12 degrees. You need to be in degree mode. Everyone make sure you're in degree mode. Everyone's typing it in. Go put your calculator in degree mode. Make sure you're not on your phones. So you're in degree mode. You're going to type in what? Cos of 12 in degree mode. And what do we get to 3 decimal places?
0.97.
And then we type in sine of 12. And we get 0.208. Okay? What did we do yesterday? You remember? We talked about all the 6 trig functions. We had the 3 primary trig functions and then the 3 secondary trig functions. So we have sine, your resume, and what does it go with? Which trig ratio does it go with? Yeah, CSC. Now, I realize, one second, if this is y over r, what's CSC? R over y. And I wanted to show you this because I realized, guys, stop please. I realize that you don't actually know what the heck this word is because it's not written anywhere. It is cosecant. That's how it's written. So that's what CSC stands for, cosecant. Then we have cos theta, which is cook extra rice. And it goes with what? Do you remember? Yeah, the sec, which is secant. So it's r over x. And this is actually written as secant. Just so you know what the heck I'm even talking about. And then our last one is
Texture X.
It's really hard. I want to say tan your X plus. Texture X by Talons, of course. Okay. Then it goes with cotangent, which is X over Y because it's reciprocal. And we say cotangent. You don't ever have to write these words. I'm just proving it to you because I realized none of you even know what I was saying yesterday. Cotangent. Okay? Yesterday, you didn't bring any game yesterday. Okay. So, yesterday I gave you a what? And then asked you for 6 trig ratios. Do you remember? I gave you a?
Cosine, sine.
Nope. I gave you something. Yeah, coordinate. Thank you. Liam has brought A game today. Okay. I gave you a coordinate. So I'm going to give you this coordinate. Shh. Here's your coordinate. It's -2, 4. What am I going to want? All of the 6 trig ratios. Go quickly. It's true. Okay, we have xy. We need r squared equals x squared plus y squared. So r squared equals 4 squared plus -2 squared. R squared equals 16 plus 4, which is 20. Then I take the square root. And what is the radius always? Starts with a P, rhymes with positive. Positive, yes. Okay, so we have a positive root 20. X and Y would have to give you a quadrant, right? Because X and Y's can be positive or negative, but your radius is always positive. Now, root 20 is what people leave it at, and you'll never have the answer correct. They'll always give it to you in a reduced form. Okay, so if you leave it at root 20, you're going to be in trouble. So we go back to grade 10. Root 20 breaks down into 4 and 5. You always try and get a perfect square. The 4 comes out, and it becomes a 2, and we have 2 root 5. Okay. So R equals 2 root 5. Okay. So sine theta. Sine is sine your resume. So it's 4 over 2 root 5. The 4's can cancel, or the 2 can cancel. So this becomes a 2 up here. So I get 2 root 5. But from grade 10 you learn, actually it's grade 11, not grade 10, that's a lie. You learned how to rationalize your denominator. So what do you have to do? Get rid of this. Yeah, multiply by square root 5 whenever you have a monomial. So last year you had learned in grade 11 to rationalize the denominator with a monomial, you just multiply by what the radical is. Even if there's a number in front. Even if I had left the 2, I would still multiply by root 5. But if there was a binomial, so a plus or minus sign, you'd learn to multiply by the conjugate. Which was, if it was like root 2 plus 5, you'd multiply by root 2 minus 5. But a monomial, you just multiply by what's in the denominator. So we're going to get 2 root 5, because you can't put them together, because one's a coefficient and one's a radicand. And then root 5 times root 5 is 5, and then that will be your answer. So if you're leaving it as root 20, they'll say, determine, if this is a numeric response, let's say, they'll say determine the value of sine theta in the form a root 5 over b. So a root 5 over b would be 2 and 5 would be your answers. But if you left it at root 20, you're not going to get a root 5 over b. You're going to get a root 20 over b. It's not going to match, and you're either going to freak out or just be like, good enough. And put the numbers, which is not going to go well for you. Okay? Then we have Yo. Did you ask something? It's okay. I thought you said so. Not at all. Okay, cook extra rice. So we're going to get -2 over 2 root 5. The 2's cancel. We're left with -1 over root 5. And what do? Rationalize by doing what? Yeah, root 5 again. These are the 2 hardest ones because they're the ones where the radicals are going to be in the denominator. But my reciprocals of those, the radicals will be in the numerator, and that's fine. You just can't have a radical in the denominator in Math 30-1, but you can in calculus. It makes no sense. So there's that. So that's cos. Tan is tan. Oh, texture X. I'm not going to adapt. This is not going well.
We don't tank or anything.
I do. Okay, So it's 4 over negative 2, which is just negative 2. And then we do the reciprocal trig identities. So what goes with sine? Cosecant. Its bestie is cosecant. So if it's sine your resume, this is resume your. So it's going to be 2 root 5 over 4. And then I can actually take a 2 out of both. And I'm left with root 5 over 2. Whenever you cancel off and you do a slashed line, what are you actually drawing? A 1. Right? These are always just 1s. So 1 times 2 is 2. Okay, what goes with what's its bestie? Secant. So if it's cook extra rice, it's rice extra. So we're going to have 2 root 5 over negative 2. Now I told you, you can leave it like this, root 5 over negative 1. It just will never be an answer that they're going to give you. So what happens when you have a negative 1 in the denominator? It just goes to the top. So we get negative root 5. And then cotan is besties with tan. So text your x, not good. Negative x your. So it's negative a half. Okay. So what we've noticed when we've done all of these is actually what happens is if we find sine, could we not, Jackson, if we find sine, could we not just flip sine? You're still talking. And get you cosecant? Right? If I did that here, though, if I flipped sine and then got cosecant, I would actually make my life harder because it would be 5 over 2 root 5, and then I'd have to rationalize it. So in some instances, it's not faster to do that. But you can. So yesterday we talked about, okay, if I wanted cos of 30, you would go to your unit circle and you'd give me the what? X or Y? X, because it's Calgary Stampede, cos then sine. So you'd give me root 3 over 2. We discussed that. We discussed if I gave you sine 30, what would you have? 1 over 2 because we pulled the y off. What about tan of 30? Tan 30 is actually, if we forget what it is, remember on our unit circle, or on our formula sheet, very top one, sine theta over cos theta. So it's going to be 1/2 divided by root 3 over 2, which gets me 1/2 times 2 over root 3, which is 1 over root 3. Remember this, that really long one? Root 3, we get root 3 over 3. So remember I told you all tan 30 reference angles are root 3 over 3? Remember that? All tan 30s. It's even better to just memorize that, to be blatantly honest. Tan 45s, what do we get?
No, 1.
You get plus or minus 1. So here, tan of 30, we get root 3 over 3. If we did tan of 150, we'd get negative root 3 over 3 because it would be in that quadrant. Tan 45, because of cast rule, remember that? Tan 45 would be 1, but why would it be 1?
Divided by the same.
Yeah, your y and your x are always the same as 45, right? Sometimes, though, it might not be positive 1. Sometimes it might be negative 1. And using cast rule, tan is positive here and here, so that's where I'm going to get positive 1s. And then here and here is where I'm going to get negative 1s, because one of your x's and one of your y's is negative. Right? Okay, and then tan 60 was the nice one. We always tried to get that one. Because what does tan 60 result in? Just root 3, because we get root 3 over 2, the y divided by the x, which is root 3 over 2 times 2 over 1, which gives me root 3. So that's your reference angles for tan 30, 45, and 60. What we didn't go over yesterday, and which we're going to start right now, is we're going to do what if I ask you for the secondary trig ratios. So what if I ask you for cosecant, secant, or cotan? What are they just? Just the reciprocals of the answers on the outside of the circle. Sounds easy. Most messed up ones ever. Because what people will do, if I give you cosecant of 60, people will tell me that's sine of 1 over 60. Are we flipping an angle? Are we ever allowed to flip an angle? No. You can flip answers. You can flip what it's equal to. That's the reciprocal. We flip answers all the time. You can't flip angles. So if I want cosecant of 60, I actually want sine of 60 first. So if I'm ever given a secondary trig ratio, I find the primary one first. So what's sine of 60? Root 3 over 2. Everyone should be looking on your unit circle because Talon can't give you all the answers on the test. It's going to be really awkward and weird. Okay? So go to your unit circle. Every single one of you, go to your unit circle. Put your eyes on your unit circle. It's in a plastic sheet. You should be able to find it quite quickly. So you go to your unit circle and you go to 60 and you take off the y because it's sine and you get root 3 over 2. We agree? We're allowed to flip answers. We're not allowed to flip angles. I'm going to embed that in your brain in hopes that you don't do that for the test. Flipping answers, not angles. So can I flip the 60? No, it's an angle. Can I flip the root 3 over 2? Yes, it's an answer. So if sine of 60 is root 3 over 2, cosecant of 60 is 2 over root 3. Now, why is that? Let's think about it. Sign your resume. And what did we say cosecant was? Resume your. It makes sense that it can flip, right? Your y's and your r's are just flipping. We agree? However, I'm not done because I have to do what? Rationalize my denominator. So I'm going to get 2 root 3 over 3. So whenever I get a secondary trig ratio with whatever radian measure or degree measures beside it, I find the primary one first and then flip. Okay? Now these are all nice because I'm giving you ones right off your unit circle. I'm going to give you another one right off your unit circle in radians, and then I'm going to give you ones that are outside of the 0 to 360. So what's the first thing you're going to have to do? Yeah, minus 2 pi or minus 360 or add 2 pi or add 360 to get it on there and then pull the answer off. You get the coterminals. Okay, so I'm going to give you secant of 7 pi over 6. Try it out. Okay, I want to also explain why it flips in another way. So we need cos of 7 pi over 6. Cos of 7 pi over 6 is negative what? Negative? I don't know where I was going with that. It's a 30-degree reference angle, so your coses are always root 3 over 2s. Now, James asked a question which is true, and I'll show it to you that way as well. If you're ever stuck, so you're like, you see a secant 7 pi over 6, and you're like, oh, Lepp, I forget. Take out your formula sheets. They should be your best friends. I told you, your formula sheet and your unit circle should be besties with you right now. Take them both out. Because you need to know what's on your formula sheet. If you're searching, that's a problem when it comes to the test. So if you look at your formula sheet, if you look at the top right, and we go to look for secant. Up here it says, and I showed this to you yesterday because I told you that's how you can, if you forget which one goes with which, it'll tell you. It says here that secant is 1 over cos. Do you agree? So you could just go use this formula off your formula sheet. Could we not? So if we want secant of 7 pi over 6, I'm going to write it down here so I have some room. We could just go 1 over cos 7 pi over 6. Could we not? And then we would get 1 over negative root 3 over 2. What did I tell you, though, if we start stacking fractions? Stop stacking fractions. Don't stack fractions. What should you do? Put them sideways. Stack them. Okay, so you would go 1 divided by negative root 3 over 2, which is actually 1 times 2 over root 3, which is why it flips. You see that? It just flips it. So you can go through all that work if you're stuck. Or you can say, hey, I remember this. I can flip answers. I know that cos is x over r. So I know that secant is r over x. So I'm just going to get negative 2 over root 3, which is correct, but not going to be the answer that's there. So we're going to have to rationalize it. You know what I mean? So we have the x and the r with the r of the x. So you can totally go that way. Absolutely works. So multiply by root 3, and we get negative 2 root 3 over 3. Okay, here's some challenger ones, guys. You just have to get a coterminal angle. It's not like making you run a marathon here. Okay. Not making you do the beep test from like gym. Oh, it's terrible. Okay. So, ready? I want secant. I'm going to do secant and cosecant again, and then I'm going to do a cotan. So secant, not theta. Okay, I want secant of What do I want? What do I want? 11 pi over 4. I want secant of 11 pi over 4. And I want cosecant of negative 5 pi over 6. All right. What if I give you this? Secant of 11 pi over 4, it's too big. So I take my 11 pi over 4, and I subtract 2 pi. So I get 11 pi over 4, subtract 8 pi over 4, because I multiply by 4. And I get 3 pi over 4, which is on my unit circle. So secant 11 pi over 4 is actually the same as secant 3 pi over 4. Why? Because their arms terminate on the same spot. And if their arm terminates on the same spot, their cos answer is going to be the same. And their cos answer is what flips to get me my secant answer, correct? So if I can just get the terminating arm to be coterminal and land on it, I'll get the same answer. Now, I'm going to find cos of 3 pi over 4 first, because that's going to help me in my striving for goodness here. So 3 pi over 4 is what? What's cos of 3 pi over 4? Negative root 2 over 2. So what's secant of this? 2 over negative root 2 or negative 2 over root 2, whatever. Multiply by root 2. And I get negative 2 root 2 over 2. The 2's cancel, and I'm left with negative root 2. Okay, what about cosecant of negative 5 pi over 6? Cosecant of negative 5 pi over 6? Because we have to find negative 5 pi over 6 and add 2 pi. We're going to multiply by 6, multiply by 6. You get negative 5 pi over 6 plus 12 pi over 6, which gets me 7 pi over 6. Then I go and I find sine of 7 pi over 6. Sine of 7 pi over 6 is negative 1/2. We agree? So what's cosecant of it?
Negative 2.
Negative 2. Okay, what if I give you cotan? What if I give you cotan of, let's think about this, cotan of 60. Let's go back into our brain cells. Let's dig deep. Okay? Tan of 30 gets me what? Root 3 over 2. Or root 3 over 3, sorry. Tan of 45 gets me 1. Tan of 60 gets me square root 3. This goes with tan of 60, right? So if tan of 60 is root 3, what's cotan of 60? 1 over square root 3. Multiply by root 3, multiply by root 3, and I get root 3 over 3. Now, what if I ask you for tan 225? Tan 225 follows what reference angle?
45.
45, correct? And tan 225 is here. Correct? What's tan in that quadrant? Positive. So it's going to be positive 1. So if I wanted cotan of 225, positive 1. At the 45, cotan and tan are the same. Flip a negative 1 or flip a positive 1, you do the same thing. Right? Okay. What if I give you this? Cotan of 330. Cotan of 330. If you're helping him, go ahead. So cotan of 330 falls here. Using cast, is it going to be positive or negative? Negative, because tan and cotan are positive here and here, right, besties? So it's going to be positive. And then 330 If I want tan of 330, what reference angle is that? It's 60. No, it's 30. And what's the answer to 30? Root 3 over 3. So this is going to be 3 over root 3. And sorry, it's negative. I don't know why I put a positive. Sorry, negative 3 root 3 over 3, which is just negative root 3. If you haven't noticed, cotans of 60 are actually the answers to tans of 30, and tans of 30 are cotans. These are opposites. So tan of 30-degree reference angles is root 3 over 3. Cotan of 30 degrees is root 3. Tan of 60 is root 3. And then cotan of 30 is root 3. They're like actually the opposite because they just flip. Okay? Now, we have about 12 minutes. Over these 12 minutes, you are going to write down some dates. So, here's your first date. April 27th. If you don't know, that's today. Then we have April 28th. Then we have April 29th. April 30th. Then you have May 1st. May 2nd. May 3rd. It is necessary. May 4th. I don't know what date we're on. May 5th. May 5th, May 6th, May 7th, May 8th, May 9th. See all these days? Those are the days you have to study in to not stink on your cumulative. Okay? So, if you know that you have work on one of the nights, or you know you have a rugby game, or you know you have track and field, or you know that your night is almost used up on that night, right? Which will happen. If you know that, you're going to go to that day and you're going to say work, or whatever it may be. Badminton, I don't know. Put your things down. Now, your work, it doesn't take up the whole night too, so you can figure out other nights, other times as well. But you need to, on here, in your own scheduled way, these are your units that you have to review. We have polynomials. We have transformations. We have radicals, rationals, other functions. That's where you add them, multiply them, compose them. Exponents and logarithms. I'm specifically not giving you any homework tonight because we've reviewed everything from the beginning of Trig, and we reviewed all the things we had left is for chapter 4 is to solve tomorrow. That's what we're going to do last. We're going to solve. Then we're going to move on to trig graphs. And then you have a test after that as well, but I might put the trigs together. We'll see. But tonight is open, so you're like, don't procrastinate. It's going to go ugly. I'm not even joking. And you guys need to make timelines for yourselves because in university, no one does it for you. You'll either have 2 classes that are 80 minutes a week or 3 classes that are 50 minutes a week. It flies. Okay? It's also great to make plans because you're going to have finals in June as well, or you might have chemistry tests or something throughout this, right? So you might be studying for chemistry on May 1st because you have chemistry tests. Well, these 2 are gone then, right? So make yourself a timeline that you can know that you get to go through all the different things. Remember, I also have review podcasts for each of the units, I think, on there. I can't even remember. I had review podcasts for other functions, polynomials. I'll have to go look. You can watch the review podcasts too, at the very least. Go through, do the review packages for that too, right? But you're going to make yourself a little timeline and figure out how you're going to make your life work. That's for you. That's for the last 8 minutes.